Okay, let's talk about what they call dot plots. Okay, so here we have some data. Maybe you don't know American football, so this has to do with American football, but it doesn't matter. Uh, we have, for example, here's one player. Here's another player. Here's another player. Here's the team that they play for. Okay, and then this is how far they kicked the ball, or the longest distance that they kicked the ball. And this is the longest distance that he kicked the ball, is 47. And 53 is the longest distance that he kicked the ball. Okay, so we have this data, and we want to create what's called a dot plot for this. So it's very simple. What's the smallest value in here? 26. And what's the largest value in here? 57, right? So we want to make a line that includes 26 and 57, since we want to be able to show all the data. And then we just start putting in dots. So, for example, the first one is 54. So we go over to 54, and we put in a dot there. And the next one is 47. So we go over to 47, and we put a dot there. And the next one is 53. So we go to 53 and we put a dot there. And the next one is 45. So we put a dot there. And 26 and 56 and 56. So 56 and 56, we see we have to put a dot and another dot. We just put the dots on top of each other. We stack them up this way. Okay? And that's what we mean by a dot plot. So it's very simple to do. Okay? Now, we can use this picture, this is a picture of the data, to help us understand a little bit about the data. And so they examine it here. So let me make this bigger. So they say, as we examine the dot plot, we notice that there are two clusters or groups of data. So what are they talking about there? Do you see two clusters? Well, what they mean is here's a cluster and here's a cluster. Approximately 70% of the kickers made, this is what we call this, these are called field goals. But anyway, 70% of the data is between 50 and 57. Is that true? Well, here's 50 and here's 57. So they're saying most of the data, 70% actually, is here. All but one of the remaining kickers, or all but one of the remaining data points, were between 43 and 47, here. The remaining one, all but one, they mean all but this one. In addition, one kicker, one data point, had a longest goal of only 26. Okay? When this occurs, we expect that such a data value could be what we call an outlier. So what do they mean by an outlier? An outlier means something that lies outside of the rest of the data. So values that are either very small or very large relative to the majority of the values in a data set are called outliers. So we could call this one an outlier because it's very far away from the rest of the data. Okay? Lies very far away from the rest of the data, so we call it an outlier. Okay, they also say data plots are very useful for comparing two or more data sets. To do so, we create a dot plot for each data set with number lines for all the data sets on the same scale. So we want to make these on the same scale, these number lines. We place the data sets on top of each other, resulting in what are called stacked data plots. So let's see what that looks like. Okay. So I guess they mean like this. So now we can see this is like one half of the U.S. players, sorry, one half of the U.S. teams belong to this league, and the other half of the U.S. teams belong to this league. So we can compare this league to this league by doing this kind of visualization, stacking them on top of each other. And let's let's see, can we notice anything about this? Looking at the stacked data plots, we see that the majority of the distances, the majority of the data points, in other words, fall within a range of 7 yards. What does that mean? I don't know. What does that mean? I guess they mean from here. They say from here to here. That's 7 yards, 7 units. In the other one, it's between here. Well, I guess they're saying between here and here. Okay, maybe. Both the AFC conferences means both the AFC and the NFC have one outlier, and with the shortest distance being 19. This one was 26, this one was 19. Okay, so we can do that. In practice, dot plots and other statistical graphs will be created using statistical software, so you don't have to really do it. Okay. All right, let's go through a little bit more here. Uses and misuses. So they talk about well, you can read this yourself. Mini project. So I want you to do the mini projects. The first one is using the dataset you gathered in Chapter 1 mini project. Prepare a summary of the data that includes the following. So, an appropriate type of frequency distribution table for one of the quantitative variables, and then compute the relative frequencies and the cumulative relative frequencies. Okay, so you have your data set. You want to work with, you have several different variables. They want you to work with one of the quantitative ones and compute a relative frequency and a cumulative relative frequency. Now, as I recall, they didn't show you a graph of the cumulative relative frequency. I made some comment about it, but I don't think they gave us an example of that, but I did discuss it, so you can go back and check that, or you can look it up on the internet, or you can just figure it out from the name. Next, create a histogram, a stem and leaf display, and a dot plot of the data. Comment on any symmetry or skewness in the present and on the presence of clusters and any potential outliers. Now, we didn't talk about skewness, so I'm not sure why they ask you to do skewness. So you can skip the skewness. And even symmetry, we didn't really talk about it, so let's skip those. But you can do this, and you can do this. Okay? Okay. Then make stacked dot plots of the same variable. For example, if your quantitative variable is GPAs of all students, your categorical variable could be gender. So what they mean is, suppose one of your okay, a little bit complicated, but what they mean is, suppose that one of your quantitative variables was GPA of students, okay, the grade point average of students. Now you have a categorical variable, at least one, in your data set as well. So, for example, suppose your categorical variable was gender. You know, maybe it's not, but just let's suppose that it was. One of your categorical variables was gender. Then what you can do is you can look at just the males and look at and make a dot plot for just the males. And then so you have to separate the data so that you can do that. Look at just the males, in other words. And then do the same thing but just for the females, and then you can stack them. Okay? Now, suppose you don't have a categorical variable that only has 2 levels. Like gender only has 2 levels, male and female. But suppose you had like favorite color, and you had 4 levels, like red, blue, yellow, and green. You can still just choose like red and blue. So do a dot plot for the red, for example, of GPA students, and then a dot plot of maybe the blue for the GPA students. Now, you probably don't have GPA students, but I think you get the idea. Okay, so that's what you're supposed to do. Okay, next. Well, I think that's enough for the mini project. So this mini project should be handed in to Blackboard. I'll have to make a homework assignment for you for week 2 homework assignment, and that will be due the day before class, so midnight the day before class. Okay? Not this one, just this one. Okay? All right, let's take one more quick look here. By the way, they have data sets here. But, oh, we know that. Okay, and let's look at this. Does this have anything in it that we need to look at? Okay, let's quickly look at this. Organizing and graphing data in Excel. So actually we did the histogram. Here we have a categorical variable called stress level with 3 so-called levels, or 3 variables, values for it. Here they teach you how to create a tally. In other words, to create a get the frequencies automatically in Excel. So you have your data here. Maybe it goes down way past 7. Maybe it goes down to 100. Now you put these formulas in the tally column. You put the response here and these formulas in the tally column. So it's count if A to A, C2, count if A, semicolon, full colon, A, C3, C4, and it counts in here how many there are of the nones, how many there are of the somewhats, and how many of there are of the varies. So that's what you get here. Okay, so that's this using this formula here. So you can check that out. Then you can also take this data and make a pie chart out of it. So you can use this, and you can generate a pie chart like this, which is pretty nice. And organizing and graphing your quantitative data, you can do the same kind of thing, but you can also have this data as well. So you can put in the min and the max into D3 and D4, and you can also get the number of classes and so on. And also, I guess there's a function here called frequency, which we could try to use. And then you can use this, once you get it, to make a bar chart. So that's nice. Now here they have a histogram. I'm not sure if they use the here. They're using the data analysis tool pack, just like we did. So we get that. And then they talk about how to do cumulative frequencies in Excel. Okay, so if you're interested in that, you can check it out. Okay, that is the end of chapter 2. So you have some homework. You have the mini project. You can also use the self-review, and you will have homework due also the day before class. So don't forget to check in Wiley Plus for your homework assignment. Okay, that's the end of chapter 2. Next week we'll do chapter 3.